A small pebble dropped in a pool of still water creates ripples on the surface. These ripples form concentric circular rings around the source of disturbance and spread outward along the surface. When these ripples reach a point on the surface of water, the point starts oscillating up and down. Different points, which are at the same distance from the source of the disturbance, oscillate in phase. That means all these points reach the crest or trough at the same time. The locus of all such points having the same phase of oscillation is called a wavefront. In case of water waves on the surface of water, we observe circular wavefronts. Each circular wavefront is a locus of all points having the same phase of oscillation. The propagation of the waves can be understood by studying the propagation of wavefronts. An outward normal drawn at any point on the wavefront represents the direction of the wave at that point. In terms of energy, we say that the energy of the wave propagates in a direction perpendicular to the wavefront. The speed at which a wavefront travels is the speed of the wave. Waves on the surface of water are two-dimensional, and hence the wavefronts are circular in shape. But the waves from a source of sound or a source of light in a homogeneous medium spread in all directions and are three-dimensional in nature. Now consider a point source of light placed in a homogeneous and isotropic medium, emitting light waves in different directions. If the medium is homogeneous, the speed of light waves is the same throughout the medium, and if it is isotropic, it is the same in all directions. The loci of all points which have the same amplitude and vibrate in the same phase forms a sphere with its center at the source of light. Hence, a spherical wave front is generated when a point light source is placed in a homogeneous medium. At a large distance from the source, these spherical wave fronts have large radii of curvatures. A small portion of a spherical wave front at a very large distance from the source can be treated as a plane wavefront. In physical optics, we visualize light as waves and wavefronts. In ray optics, we visualize light as rays. A line drawn perpendicular to the wavefront in the direction of its propagation is treated as the ray of light in ray optics. Note that a wavefront is a surface of constant phase. If a particular wavefront is a locus of points with maximum amplitude, it continues to be like that as it propagates through the medium. Huygens